Hello everyone, in this video I will be showing you how to work with hypothesis testing using Microsoft Excel for regression. First of all, I'll just show you how to come up with p-values and test statistics and all the necessary information that we want regression line for a given variable, okay, for a given two variables. And then I'll go to one of the questions and I'll try to show you what we need to do. Okay, so here I have come up with a random example of height and weight of various persons, different persons. The height must be in inches, looks like that, and the weight are in pounds. Okay, so we want to see whether there is any kind of correlation between height and weight of these people. Okay, we first of all see how to plot the data. Okay, so first of all, select this. Go to insert and click on recommended charts, and you might want to go for scatter plot. Okay, and this would be the scatter. All right, once you have done this one, it looks fine. However, this is not a nice representation of this data, so I would like to show you how to make it nicer. Okay, so for that, first of all, let me go for axis titles. Okay, that looks fine. And to throw away this empty spaces, click on this plus sign and go to access and go for more options. Okay, this way you will be able to throw away this one. So you can see that this below 50, we don't need this space. So go for x-axis. Okay, here you can see this is axis. Since this is selected, so that's why we know that this is x-axis. Okay, so minimum is you write down 50 over there and then click on enter. Then you can see it is much nicer than the previous one. Okay, so this looks good. Now let us go for this. Let us write down this height versus weight. Height versus weight of several people. This one is height, of course, right? So that's x, right? Height in inches, and this is weight in pounds, right? Now we want to come up with trend line. Okay, so that's where we go. Click a tick, choose it, go for more options. So display equation on chart, display r squared value on chart, so that's over there. So click on this line and you might want to make it a bit nicer. Color, I just want to go for red just to make this thing distinct, and compound type red line. This is how we get scatter plot and then draw a trend line, which is the linear regression line or a line of best fit, and we get its equation and the r square. Okay, the correlation coefficient squared. All right, now this is fine. Okay, we know how to do this. However, we might want to go for hypothesis testing. To go for hypothesis testing, what we do is we go for data and we go for data analysis. If you don't see this data analysis tab on your Microsoft Excel, then head over to file and then go for options and then click on this add-ins, and then in the middle you can see manage Excel add-ins. So choose Excel add-ins and click on go. Then this should be checked mark. Okay, analysis tool pack should be checked mark. Okay, click on OK, and then you should be seeing data analysis. If you can't see data analysis by doing that again, then just restart Microsoft Excel and do the same process. We might want to go to data analysis and go for regression. Okay, so where you go and click on OK. Then you might want to choose the X level and Y level. X level is always the first one, the first column, and Y level is the prediction that we want to make. Okay? So according to the height, okay, given height, what would be your prediction? That's what we want. And we have already realized that height is the x-axis, x, and weight is the y-axis. So weight is the one we need to predict. Okay, we want to predict. Go to data analysis, click on regression, click on OK, and then you'll be getting input y range. Y range is this one. Just click choose all of them. Click on x range and choose the next one, the x-axis. And labels, yes, you put a tick mark on labels. Since there is height and weight, we have labeled it in that way. And okay, confidence level, how much confidence do you want? Do you want 99% confidence or 95% confidence? What do you want? Okay, and you want this output range to be in a new worksheet, that's fine. And you can go for residuals, standardized residuals, and blah blah blah. Line fit plots, you can go for anything. Okay, so let me go for line fit plots, and it will give me everything in a new worksheet. Okay, click on OK. So you can clearly see what is happening over here. Okay, so it is giving me everything. Now this is not a nice data set that you want to go for. However, it is just showing us the predicted line, right? Okay. And we know that this is empty, so and we are better off over here since we deleted all the things below 50. That makes it much nicer, right? Okay, so here you can ignore this one. Hold on. Here you can ignore this one, and I just want to focus on this table. Okay, not that. Okay, we are not going to look onto this table, the second table over here. However, we want to go for the first table over here. R squared is 0.4369, and standard error is 4.61. That is the SSE, okay, sum of squared errors. And yes, 0.4369 was the error, sorry, R squared. So that looks good. And we are not going for this ANOVA. Here, I would like to let you know about few things over here. So most of the important things that you need to go for is the coefficients, okay? Coefficient. The intercept is 79.98. What is that? Okay, 79.98 is the intercept. That's the y-intercept. Similarly, this 1.259 is the slope of this line, right? And test statistics is this one. For height, the test statistics is 3.73. And the p-value for this one is 0.001. And now you can clearly realize what we had done previously, right? I think we went for 95% confidence, right? Or if you can just look for this one, yeah, 95% confidence level. So this looks good, right? Okay, since this is less than 5%. 0.001 is way less than 5%. So now this is how you get the equations, okay? Y equals to 79.9848. So that's the y-intercept, plus 1.2596 is the slope of the line, right? Okay, so that's it. Okay, let me copy this one and paste it in the worksheet. Okay, so that way it will be much more easier for us to realize what we are doing over here. Okay, Control P. Okay, so now if you want to make a prediction, what do you do? Okay, suppose you want someone whose height is, let's suppose, 62, whose height is suppose 62. You don't have a value over here. You want to predict their weight. Okay, so for 62, what do you do? Okay, so for that, what you will do is you will write down prediction over here, and you'll use this equation. I think it's better to just simply go for write down this one. Okay, so ignore this y. Y is this one. Okay, we will be ignoring that, and write down 79.9848 plus 1.2596 times, then comes this x value. Okay, what is the x value? Okay, so x value for this y is 55. So you choose this cell. I hope that makes sense, right? You start for the prediction, you start from equality sign. Okay, 79.9848 plus 1.2596 times a2. A2 is the x, and then click on enter. Once you have done that, then double click on the right bottom. Once you get the plus sign, and once you get the plus sign, this kind of sign, and then it will auto populate the estimation, okay, or the prediction. And you can see that these are very close values, right? Okay, so for 60, you can see that's 155.56, 156, that's fine. 54, 142, this is 148, slightly off, but however, you know, this is an approximate, right? Okay, now, as I was telling you, there are several values that we want to predict. Let's suppose, so let us go for, this is 62, that's what we want to, and let's suppose go for 64.5, this value we don't have in there, and let's go for 65 and 58, 59, These are the values. So you can clearly realize what is happening over here. Now, if it doesn't change automatically, then you can again you can just drag it down by clicking on the left side. So you can easily see how this is predicted. Okay, so 62, you just go over here and it is calculating itself, right? 79.98 plus 1.25 times A22. A22 is 62 and we get 158. Yeah, for 63, you can see 159.33. So 63, 159.33. For 64, it is nearly 162. So quite close, right? Okay, so this is how you go for estimation. Okay, and I hope you understood what I said over here. Okay, so the t-stat and p-value, they are significant for this height only. Okay, don't go for the t-statistics for the intercepts. Now let me go for a problem that we have in our exercise, okay, which is in my open math. Annual high temperatures in a certain location have been tracked for a sample of 16 years. Let x represents the year and y represents the temperature in centigrade. This is the data. Okay. We need to calculate the correlation coefficient, and then we need to go for this hypothesis testing. Significance level is 0.01. Now, when is regression used? Regression is used when two variables are correlated. Okay. We expect the correlation between them. Otherwise, we can go for t-tests. So let us copy this data. You can just copy it, select it, and paste it in Excel. Here, this is how we go for it. You might want to draw the picture by scatter plot. That's fine. It's up to you. However, let's again go for this data analysis and go for regression. Click on OK. So y value, the output is the dependent variable is y. It ranges from 1 to 17. So there are 16 values. And A1, okay, so this is A1 up to A17 here as well. Levels, yes, X and Y are levels on the first row. Confidence level, we want to go for 99 confidence level. Since it is saying 0.01 significance level means that's 99% confidence, okay? All right, okay, then it looks good, everything fine. Okay, let me just throw away this line fit plots. We don't need that, and click on OK. So everything looks good. So you can see that we have this new table. Okay, here you can clearly see that R squared is 0.98, which means 0.9921 is the R value, okay, the correlation coefficient. And you can check that over here, calculate the correlation coefficient, 992, that's fine. Now, let's test the significance of the correlation coefficient at alpha equal to 0.01 significance level. Okay. So the null hypothesis, there is not a significant relationship between the air and the high temperature. And there is a significant relationship between the air and high temperature, okay, for the alternative. Test statistics and p-value, they are quite easy. So you can see that that's 29.748. So test statistics, we need to go for the x values test statistics, which is this one, right? 29.74. And p-value is this one. Okay, you can see that this is 4.6865 e negative 14. What does that mean? It is a very, very, very small number which has 13 zeros after the decimal point. Okay, and then at the 14th decimal value place, this 468 it starts. Okay, so let me show you what do I mean. So 0 point and write down 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then in the 14th place, you go for 46865. So that is the number that you want for the p-value, okay? P-value of x. So this is a very low p-value, right? It's lower than 1%. Okay, and if you just click enter, then it will again show you the same thing, right? See, I have written. I hope this helps you. Then you can clearly realize what is happening over here. So p-value is 0, that's fine. Okay. Now make a decision, reject the null hypothesis or do not reject the null hypothesis. So the p-value is very less than the alpha, which is 0.01. So we reject the null hypothesis. And then is there enough evidence to support that there is a significant relationship between the air and high temperature? Yes, there is a significant evidence to support there is a significant relationship between the air and temperature. This is how you go for this problem. Thank you so much.